Okay, in the last video we have tried to explain the concept of discriminant analysis. So just a recap, in the discriminant analysis, the dependent variable is the categorical in nature. So this is the example in which we are going to apply the discriminant analysis. So in this example, the gradation is the dependent variable, and gradation is being considered 1, 2 and 3. 1 means grade A, which means more than 80% marks obtained in 10 standard. 2 means grade B, between 60 to 80% marks, and 3 means grade C, between 40 to 60% marks. So this is totally hypothetical, just for explaining the concept. And the predictor variables are marks obtained in last exam, the test marks, marks for the project work, and internal assessment. The school observed that on the basis of these variables, the student got these marks from the past experience. Okay, now at the time of this time period, that means in the COVID situation, the board couldn't able to conduct the exam. Now whether this type of methodology can be applied or to predict the gradation on the basis of the internal marks or project marks or last exams test marks or this year's test marks, last exams final marks, on the basis of these predictor variables can able to derive. Okay, so discriminant analysis allows us to derive one discriminant function, okay, just like estimated regression, through which we can able to derive the discriminant score, which can identify the gradation within the cutoff marks, okay, below or above on the basis of that cutoff marks, the gradation of the students with respect to that discriminant function or statistical device derived by this technique. Okay, then which also allows us to compare the accuracy, that means that statistical equation derived gradation and the empirical or real gradation, okay, real gradation. Okay, so if the prediction is accurate more than 70%, so that is enough. Okay, maybe 80%, 90%, like this. Okay, now that discriminant function can be used to predict for those whose gradation is not given. Okay, so the discriminant analysis can be analyzed from two angles. One is descriptive discriminant analysis, another is predictive discriminant analysis. Now regarding the sample size, actually the 5 times more than the number of predictors. Here number of predictors are 4, so minimum number of samples should be 25 times more, that means 20. So it satisfies these assumptions. And another assumptions, the dependent variable is categorical, okay, and which are mutually exclusive. The predictor variables are ratio scale and interval scale. I told you it is ratio scale, all are ratio scale, more or less all are same units. So here the standardization is not essential, but in case if the predictor variables or independent variables are different in terms of their unit, then it is essential to standardize the variable. Okay, it may be taken G value, G score value, or T value, T score value, in this way. So whatever it may be, but standardization is essential. And the assumptions through which it is based on, the discriminant analysis is based on, the predictors are independent. So in this particular example, we are assuming that the independent variables are independent. There is no scientific reason that the marks obtained in last exam, any student who will also get good marks in test marks also get good marks in the project work. Similarly, the vice versa also true. Though this particular example, it is quite rational, though, that the good student should get good marks in all this, but this analysis is not only related to this example. It is related, it may be applied to any cases where the dependent variable is categorical. For example, whether the bank provide loan or not depends on the depends on whether that particular person previously has given repaid that loan, or the number of some independent variable through which identify that particular person is defaulter or not. Okay, or he has completely repaid that, so that in future, if on the basis of that certain criteria, that the credit income ratio, the age, the service, job security, so on the basis of many independent variables, the bank can able to decide whether that particular person should be allowed to give loan or not. So in many cases, in the real world situation, we can apply the discriminant analysis. So it is like the logistic regression, but in the logistic regression, we don't need the normality assumption, but in discriminant discriminant analysis requires normality assumptions. Normality assumption means that the sample has been taken from normally distributed population. Okay, it should be linear, there should not be multicollinearity, and no outlier. Okay, this is the assumptions. In this video we are going to test that to what extent it satisfies, this data satisfies these assumptions. Though this is totally hypothetical data, so we should not expect that we can able to satisfy all this anyway, but for whenever the researcher will conduct or apply this discriminant analysis, it is expected that particular analysis will be based on some field study data, and the assumptions, if the assumption it can meet the assumptions, definitely that researcher can apply the discriminant analysis. So we can export this in the XPSS software. After exporting, it looks like this. Okay, it looks like this. This is the variable view, and this is the data view. Variable view is like this. Okay, we know this. Now how to apply the for normality test? Go to analyze, go to descriptive statistics, go to explore. Okay, now you can highlight the marks obtained, and then shift key. Through shift key you can totally move the dependent variable list. Don't go for anything for the factor list. Okay, we plot here normality test and histogram. We don't need for this one histogram. Okay, continue this options, no change. Okay, click OK. Click OK. The SPSS result provides the result. On the basis of this result, we can able to explain in this way. We can able to explain just to keep some time, so that the result we can observe the result. Okay, this is the result. The first table shows the case processing summary. As we know that case processing summary, we can explain. Okay, we can explain the valid cases, number of missing cases. Okay, and like this, and descriptive, all the descriptive measurement like mean, median, variance, etc. The researcher can able to explain this one with respect to different predictor variables. Okay, test marks, marks in the last exam, that means exam in the last class 9's exam, final exam, marks in the project work. Okay, in this way we can explain. Now the important table is this one, tests of normality. This the null hypothesis is that the independent variables, each independent variables are normally distributed. Since these value are Shapiro-Wilk test, all the values are more than 0.05, more than 0.05, it shows that we have to accept the null hypothesis. That means the independent variables are normally distributed. Okay, even in the Kolmogorov-Smirnov test also, almost all except one, okay, the marks obtained for project work except one, all are normally distributed. So we can say the variables are normally distributed. We know that through histogram study also we can able to get the rough idea whether approximately normal or not the independent variable. As we know that we should not expect that as we see the bell-shaped curve, our empirical data or hypothetical data should also look like that smooth continuous bell-shaped curve, but it is roughly bell-shaped curve. Okay, on the basis of this roughness we can able to say okay, it is more or less the normally distributed. Similarly, the normal QQ plot, we know from previous videos this concept. Okay, and the presence of outlier, there is no any observation, so within that upper top whisker and the lower whisker, so the no outlier for the first variable. Similarly, test marks also we can able to get the idea that the normality assumptions and no outlier presence. Okay, now for presenting the linearity, this is for normality. Okay, this is for normality assumptions. Now according to our another assumption, that is the normality. Now linearity. Okay, linearity, what we have to do, in this way, we have to proceed in this way. First go to data. Okay, go to data, split files, organize output by groups. Click here, organize output by groups. Group means here grade is group. Okay, click OK. Then you go to graph, and you go to legacy dialog. Okay, legacy dialog, and scatter plot. Okay, scatter diagram. Okay, then scatter matrix, define. You will get the data matrix variables are, these variables are matrix, these variable, shift key. Okay, okay, now click OK. Just give some time. Okay, grade is missing